In many industry contexts, workers need to access technical information while they are already interacting with complex machines or 3D models. The problem is that this information is often hidden inside manuals, menu, or static documentation, and retrieving it can interrupt the task. Traditional extended reality interfaces can help by showing information in the environment, but they are often rigid. Users have to navigate through menus, open documents manually, or follow predefined overlays. At the same time, simply adding a language model is not enough, because in industrial scenarios, accuracy matters. We cannot rely on answers that are generated without being grounded in validated sources. So the gap we address is this. How can we connect the user is doing in the space, for example, pointing, selecting an object, or asking about for this specific component, with trusted technical documentation? LlymX stands for LLMs for XR. The idea is to let users interact naturally with the 3D scenes through speech, text, and gestures. For example, instead of searching manually through a menu, the user can ask a question, point to an object, or select a component inside the scene. Behind the interface, the system interprets the user intent, identifies the relevant 3D object, retrieves the information from domain documentation, and then provides a grounded answer. Depending on the request, the system can activate two main modules. The first one is object identification. Here the system maps a natural language or a reference, for example, show me this rack, to the most likely 3D object in the scene, using semantic, metadata, and embeddings. The second is contextual retrieval. Once the relevant object is known, the system uses its metadata to search inside the knowledge base, retrieve the most relevant documentation, and generate an answer grounded in those sources. The output can then be sent back to the extended reality interface as text, as an highlighted 3D component, or as a PDF opened directly in the relevant page. A concrete example is a user asking, show me the 6-level cart of this dishwasher. In a traditional interface, the user will probably need to browse through menus, find the correct component, open the right manual, and search for the relevant page. With LlymX, the system can combine the spatial context and the natural language request. It can provide two types of answer. First, a textual answer with a reference to the documentation. Second, a visual response, for example, highlighting the current part of the 3D scene or opening the correct page of the manual. To evaluate the system, we conducted a within-subject user study with 16 participants. The scenario was based on a washer disinfectant machine, and each participant completed 3 knowledge retrieval tasks. We compared 3 interaction modalities. The first was a menu-based interface, where the user navigates through hierarchical menus. The second was an infographic-based interface, where visual overlays appear on the selected components. The third was the LLM-based multimodal interaction, which is LlymX. The results show nuanced pictures. All participants completed the task successfully in all conditions. The clear result was usability. LlymX received the highest SUS score, and it was rated significantly more usable than the infographic-based interface. It was also comparable to the menu-based interface. So the main takeaway is that the LLM-based interaction was not proven to be objectively faster or less demanding in this first study, but users perceived it as highly usable and flexible. The qualitative feedback helped to explain this result. Users appreciated the possibility to ask natural questions, such as, what is the function of this rack? They also liked the fact that the system could open documents automatically or highlight the relevant part and model directly inside the scene. At the same time, there was some friction. Some users were initially unsure how to formulate the request. Speech recognition also creates some uncertainty because the users were not always sure whether the system had understood properly or not. And when they had to type in the extended reality with the virtual keyboard was slow and uncomfortable. This suggests that the LLM-based extended reality interaction should not necessarily replace menu or structured interface entirely. It works best as a complementary layer, conversational and flexible, but supported by clear prompts, visual cue, and low-effort input mechanism. LLM show that combining XR, semantic object representation, and RAG can support more context-aware access to technical knowledge. Thank you.